Hey guys, modern day James here, and I'm doing my first Gumroad video, and I wanted to cover some of the basics of dynamic sketching before we jump into any further topics. I figured, I have a little bit of this on YouTube, but I figured here we could delve in a little bit, further and spend a little more time on each thing. So I think the first step is to be able to hone our ability to draw primitive forms, but in order to do that, we need to be able to twist planes in perspective and draw ellipses. So I'm going to start by drawing a square just in a flat orthographic kind of way. Now, when we take this square and we want to twist it in perspective, well, first we need to figure out where our horizon line is. I'm going to just set it to the middle. And now what we're going to do is twist this counterclockwise. Or excuse me, clockwise. Extend our horizon line. I keep this line on the left the same. And now, since we're twisting clockwise, this line below the horizon line is going to be going up towards that left vanishing point that I'm creating. And the line up here is going to be angled down towards that left vanishing point. Now I'm drawing just away from it. So that's the general principle of twisting planes in perspective. Now, in order to figure out how to twist a circle in perspective, we can start the same way. We'll draw a flat square. And when we place a circle within the square, it's going to touch each of the four center points of each edge. Here I'm just estimating where they are. Another technique that we can use to figure out the center points is creating an X from corner to corner. And if we create a vertical line going through that center point and a horizontal line going through that center point, we find those center points on each edge. Now within this square that I've created, I can create a circle that would touch each of these four center points. And that's how you create it in a flat perspective. Now, if we do the same thing where we twist this box, and we'll twist it clockwise again. Again, one of these lines is below the horizon, the other above. And we'll repeat the same corner to corner X. Create a vertical. And create the horizontal. And what this does is now find each of the center points on the edges, but in perspective. Another thing that you'll notice is that this side that's closest to us is actually visually larger than the side that's furthest away from us. And that's just a side effect of perspective. The one that's closest to us is obviously going to appear larger. So if we want to create a circle within this tilted plane that's in perspective, we have to follow the same rules. It has to touch each of the four center points. The shape that's created here is called an ellipse, and it's essentially just a twisted circle, or a circle that's twisted in perspective. I'll draw it again without those bounding boxes. And you can make a few observations about ellipses and what their shapes are. So with an ellipse, we have two distinct axes, one known as the major axis, or axis, excuse me, and that's going to be along the wide end, the major axis. And then the minor axis, which goes along the shortest path. The minor axis is really great. It's a super useful tool for figuring out ellipses. It essentially acts as the head of a top or something, and it kind of shows you the tilt. I'll give you an example of this. Let's say I just create a minor axis going this way. Again, that's going to be going along the shortest end of my ellipse. You can do the same thing by creating different planes in perspective. The benefit of understanding where the minor axis is and what it's doing is that you can create a lot of different forms with it. So if we wanted to create a cylinder, what we can do is start with our minor axis. And we'll notice that the minor axis runs directly through the cylinder. So again, going back towards our right vanishing point here. And we just create another ellipse in the back. And you have your cylinder. Now, in order to understand ellipses a little bit further, we need to understand how we figure out the degree of an ellipse. The degree will change depending on its position related to the horizon line. So I'll start again by placing in a horizon line. Ellipses that are closer to the center will appear shallower in degree, so their degree will be thinner and flatter. And ellipses that are further away from the horizon line will appear wider and more circular. They'll have a much wider degree. And we can express this by, here, I'll show you how do we do this. We create two guidelines emerging from our center vanishing point in a one-point perspective situation. I'll create a square. And now within this, I'm going to find my 4 center points, and here I'm just sort of estimating them, create an ellipse. Because this is a flat box, the minor axis of this is directly vertical. Now, I'm going to use a technique that Scott Robertson uses for replicating boxes. I kind of skipped over it, I should have mentioned it earlier, but I'll draw a square in a flat orthographic perspective. Use the same X center point technique that we did earlier. Extend out horizontally. And now what we can do is we can expand from this corner vertice through this center point on the right side. And where that intersects this bottom line is where we can create a box of equal size. So now what we've done is created, in an orthographic way, we've created 2 boxes of equal size. And so we can do that same thing in perspective. If I create an X from corner to corner on this flat plane, and now I go from this far vertice through the center point. Now I've created a box of equal size, but in perspective. And we can kind of repeat the same thing. If we carry this center line all the way back to the vanishing point. And if you're familiar with this, or if you've read Scott Robertson's How to Draw, you'll be pretty familiar with the same thing. He uses it all the time. And what you'll start to notice is that if we create an ellipse in each of these boxes, not only do they get smaller and smaller, but the degree gets flatter and flatter. The same thing can be if an ellipse is on its side. So let's draw some guidelines emerging this way. Now if I create an ellipse in this box, we have its degree. The closer that we get towards the center, the flatter the degree is going to be. The further out we go from here, let's say we draw out this way, the degree of our ellipse is going to get wider and wider. So there's two rules here. The closer you get to the center, the flatter the degree is going to be, and the further down or up away from the horizon line, the wider the degree is going to be. Now that we've gone through how to turn planes and circles in perspective, let's try to build forms out of these two-dimensional shapes. So the first form that we're going to be able to do is our cube. So we take our two-dimensional square and we extrude out towards our right vanishing point. And repeating that shape in three-dimensional space in order to create volume. The next primitive form that we need to be able to do is our cylinder, which is essentially taking our circle, or in this case an ellipse because it's tilted in perspective, and extruding that vertically, or just in the direction of the minor axis. In this case, the degree of the ellipse down here is lower since we're looking down. So this bottom ellipse is further away from the horizon line, so its degree is bigger. The next primitive form is our pyramid, which is going to be a square in the bottom. And then at the center of that square, we're going to travel up vertically. And now each vertex is going to meet that top center point. Just up that line weight on the bottom one there. Okay, and now for the cone, we're going to have another ellipse on the base. And then from the center of that ellipse, travel up vertically. And now, once this ellipse is perpendicular to our line of sight, we're going to create a line traveling to the center point there on the top. And our sphere, which in any direction is going to look like a circle. You can make it look a little bit more spherical by rendering it or adding a cast shadow underneath it. So let's break these down just a little bit further. I've already shown you how we can draw through the pyramid and the cone. Same thing if we were to draw through this cylinder here, we could see that this bottom is an ellipse as well. If we're trying to draw spheres, what we can do is create two perpendicular planes in perspective. And create an ellipse in each of those. This perpendicular plane that I've created here is a little bit rectangular, so I'm going to have to fudge that just a bit. Sorry. Now if we connect these, you create a sphere. All right, now what if you want to make your own custom polygons? Well, you can do this first by figuring out what your shape would look like in an orthographic or flat perspective. So once again, I'll start with a flat square. And within that square, I'm going to draw my own custom shape. So it's kind of this weird polygon, and I'll color it in with the marker so you can see that a little bit better. So that's our shape that we're going to start with. And now we're going to expand that in perspective. So what we're going to do is we're going to take that flat plane that we made, tilt that plane in perspective, and then once again draw in that shape. But before we can do that, we need to figure out a few things. We need to figure out where the vertices of this shape are touching the box. So here, 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 and right there. So what we need to do is figure out where on the box these vertices are, which we can figure out relatively easy just by making a few notes. This top left one is right in this is the same vertice as the top left one in the box. This one's right at the center point on the left edge. This bottom one is a little right of the center point. This one on the right edge, the lower one on the right edge, is just below the center point, this being the center line. This one is a little bit below the top vertice, and this one's a little left of the right vertice. So I'm going to repeat those same things, but now I'm going to do it in perspective. So I create that plane once again, but now rotated clockwise. So I'll make those marks again on the center point, just a little below the center point. The other one's a little bit right of the center point. And this one matches there. So now I can draw in that shape by connecting those vertices together. And now again, what this is our flat two-dimensional shape tilted in perspective. Let me color that in with the marker again. And now what we'll do is expand that two-dimensional plane in perspective. And now we can expand these vertices over to the right. And now I'm just going to follow my guidelines along towards the right vanishing point. This one is pretty much at the horizon line, so it's pretty flat. So you're not actually going to see that. And this one, we're going to expand, just drawing through there. Okay, and now I'll connect those vertices again. Now I'm going to fill that in so we can see that polygon in full. And so all we did was just take our two-dimensional shape and extrude that out in perspective. And now as you get more comfortable with this, you can just do the same process, but without using those same guidelines. And you can just build out that shape. Expanding out towards that right vanishing point. And then repeating that same shape on the opposite side. So one of the other skills that we're going to need with creating primitive forms is the ability to rotate to any angle. I'll go back to traditional in a second, but I already had this demonstration recorded. So I'm starting out by creating a square in a one-point perspective, and then creating an ellipse on top. Remember that the ellipse has to touch the center point of each edge. And now I just draw in that ellipse once I've drawn in the 4 center points. From here, I'm going to extrude this top square, and I'm extruding that downwards. I'm adding a little bit of vertical convergence, which means that there's a third point of perspective where all my vertical lines are converging to. And then from there, I just create another horizontal and create my 1-point perspective box down a little bit further. And I'm just drawing through to the other side to create that bottom face. Now I'm creating an ellipse on that bottom face, and then I'm going to connect that to the top face to create a 3-dimensional cylinder. Creating a center point on that top ellipse and the center point on the bottom ellipse. Now I'm going to label the top ellipse with a clock face. The reason being is that we need to maintain this perpendicular relationship as we rotate along these degrees. So for example, if we're creating a cube that has a length that spans from the center point to 12 o'clock, it has to have a width that spans from the center point to 3 o'clock. And this relationship is going to hold true. So if we rotate the box to 1 o'clock, the perpendicular line is going to be at 4 o'clock. And we'll see how this will help us as we continue on. So now I'm creating my first line spanning from the center to 4 o'clock. And that's line A, going down from the center point to the center point of the bottom ellipse. And now from the perimeter line to the bottom of the perimeter line, connecting those together. And that creates line B. Now what I'm going to do is create my perpendicular line, which spans from the center point to 1 o'clock. Since I've already created 2 sets of parallel lines, that being lines A and B, I can either extend those back until they intersect, or just imagine where they would intersect to find my horizon line and my left vanishing point. Once I figure that out, then I can expand C to that imaginary horizon line and find the right vanishing point. From this right vanishing point, which is off the page, I'm going to extend back towards the vertice on the perimeter line there. And here I'm just indicating that those lines are going back towards the left vanishing point. And from the left vanishing point, we can expand back through line C to find that far edge there. And that's how we find our first box. All right, now I'm going to do the same exact set of steps, except now I'm going to rotate line A to 3 o'clock, creating line A prime. I expand from that left vertex down to the center point of the bottom ellipse. And now my perpendicular line goes from that center point of the top ellipse to 12 o'clock. I already have this outer box framework created, so I don't really have to do too much work since I already know where my center vanishing point is going to be. All right, I'm going to do the rest in time lapse because it's just the same set of steps over and over again. Familiarize yourself with this exercise and try to do it again without the guidelines once you've done it all the way through. Honestly, this exercise is crucial for understanding how objects can be placed at different perspectives and how rotating them creates new sets of vanishing points each time. All right, so now we've discussed how we can rotate cubes in perspective, but how do we rotate ellipses in perspective? And I'll show you how we do that. First, I'm going to start by drawing a plane tilted in perspective. Within that plane, I'm going to draw an ellipse. In this case, our horizon line is just dead center. And our right vanishing point, maybe out here, we'll say. In this case, our minor axis is going to be completely horizontal because it's the center of the ellipse is directly on the horizon line. Okay, so the way we can do this is by creating square forms that have a length and width of the radius of this ellipse. So here's our radius r. On the perimeter of this ellipse, we're going to go from the right vanishing point and out. And create our square form. And then bring it down to the minor axis. Now, if we rotate this first line, let's do it to a 45-degree angle, we know that these two lines are the same length, R and R. Although they might not actually be the same length on the piece of paper, that's because we're in perspective. We can go through this point again, traveling away from that right vanishing point. Connect it back to the minor axis. If we rotate it again, and let's say we rotate it to the perimeter, well, now it just looks flat. Rotate it down again to another 45-degree angle, away from that right vanishing point, and back to the minor axis. And now we'll do one last box, but we'll do it vertically, away from that right vanishing point, and back to the minor axis. Now that we've placed these boxes in perspective, again we know that the ellipses are going to contact each of the 4 center points of these boxes. I'm not going to do this first one. I want to just show you how this looks when we twist it. An observation that you can make about these is that the minor axis at any tilt or rotation is going to be equivalent to the tangent line along the perimeter. The tangent line being, let's say we have a circle, our tangent line will contact at one point. So our minor axis is going to be equivalent to these tangent lines. So let's try this again, but now I'm not going to use all of these guidelines. I'm just going to start by building out those square planes. It almost looks like taking a book and folding out all the pages. I'm just going to create the ellipses in the ones that are tilted. Again, hitting those center points of each edge. And now you can really see that the minor axis is that tangent line here. I'm just sort of winging where we're putting those center points. I'm just kind of eyeballing it. And this is a really important thing to be able to do, just be able to create an ellipse and be able to figure out the perspective, maybe by reverse engineering it. Let's say I create this ellipse. Well, now I can create a cylinder based off this minor axis. Then because this next one is further away, the degree of it is going to be a little bit more circular. And let's say we want to keep rotating this. Well, now, if we're rotating it away from us, the degree of this minor axis the degree of this ellipse on the base is going to get bigger. And more circular. So we just want to get comfortable with these minor axes and ellipses and just being able to rotate them in any direction. So I want to talk about how we can modify these primitive forms. The first one we're going to talk about is welding primitive forms together, which is essentially just attaching two different primitive forms to one another, or multiple. So I'm going to start with a cube. And attach that to a pyramid. We can do this with some other primitives. We'll do it with a cylinder and a cone. Another primitive modification we can do is shearing, which is essentially slicing off a piece of our primitive form. We're going to first start by creating our primitive, in this case a cube. Then I'm going to create a plane, in this case a tilted plane, that's going to slice through our object. Where this plane intersects with these edges is where I'm going to slice. So now let's combine the two together. And what we get are two separate objects. Now I'm going to separate it from the object below it. Now I'm just increasing the line weight of that one that's in front. And what I just did there is called an exploded view. And that's when you pull one piece out in perspective. We can also do this with our rounded forms as well, like our cylinders and cones. So first I'm going to start by slicing horizontally along a cone. Just starting out with part of that ellipse and then the center point. All right. Now I'm going to draw an ellipse with a vertical minor axis. If you want to wrap that in a form, you can do that. Here's that minor axis being vertical. This bottom ellipse could be just a little bit rounder. I'll just touch that up a bit. Now, the top face of the bottom part of this, the top face of the bottom part is going to be the same exact ellipse. A slightly more complicated transformation is if we take a cylinder and cut that on an angle. So I'll do that. right. So I'm going to draw a flat ellipse with a vertical minor axis. Just create a bounding box for it. Now what I'm going to end up doing is create a tilted plane from this. So from these vertices, I'm going up. Now I'm going to create a diagonal down here, going towards that right vanishing point that I've created, and back down. And again, we've talked about rotating ellipses. So we create that angled ellipse. Get that ellipse on an angle. Now, the bottom of this cylinder is going to have that same angled ellipse. And then the top is going to be an ellipse with a vertical minor axis. The next modification we'll talk about is rounding out our forms. So I'll start with a hard-edged cube. And what we're going to do is round out the edges in multiple ways. We're going to round it out on the top face and along these angles here, and you'll see how that comes together. I'm essentially just taking those corners and just imagine filing them down. Yeah, that one's pretty intuitive. Now let's do some extrusions. We can extrude inwards and outwards. So on this front face, I'm just going to punch in, creating that flat shape, and then going back towards that right vanishing point, and now extruding up. You see this line in the back, this edge, that's cut off from our view. If you want to draw through, by all means, go and do that. I'll draw through in a different color in just a moment. And now I'm going to extrude outwards. I waited to draw in these back edges because this square that I'm extruding outwards is going to change the silhouette. See that, how it breaks up the silhouette there? And then if you want to extrude on the opposite side, so that's one way to do it. The other thing you can do is we referenced earlier, which is just sort of creating a shape In this case, I'm creating this slope and just extruding that towards the other vanishing point. And we're just going to repeat that shape in perspective. Another thing that we can do that's sort of similar to shearing is beveling our edges. That's when we're taking our edges and we're turning them into two edges. And you can also take your vertices and turn them into three vertices. So I'll show you how that works out. So we'll take our cube, so I'll take these vertices, turn them into three, and take my edges and convert them to two edges. All right, so the final topic I want to discuss is organic forms. This is going to rely heavily on our ability to create ellipses in perspective and to duplicate curves in perspective. So I'm going to start just by creating a random, seemingly two-dimensional shape. And I'm actually going to create that same shape twice. And I'm going to show you how by using cross sections, we can take the same exact shape, pretty much the same exact shape, and make it appear as though it's below the horizon line or appear above the horizon line. So as we know, any ellipse that is below the horizon line is going to go tilt down. So let's do this. And then just in the back, I'm going to make it a dotted line. Now as we go further down, further away from the horizon line, we're going to increase that degree. So it's going to get more circular. Now what we can do is create a perpendicular cross section. Again, I'm thinking in ellipses here. Our minor axis in this case, as we do a perpendicular cross section, is going to go horizontally. And these lines that I'm creating here are leading back to that left vanishing point. We can do the same thing, but now our ellipses are going to tilt upwards. As we move further down this time, now the degree of these ellipses is going to be more flat. And once again, create that perpendicular cross section. Now if we want to go across these ellipses back towards that left vanishing point, notice that it slopes down. So I'm going to sketch a California cactus. I'm going to start just by blocking in some shapes. Now, these aren't exactly elliptical, but they're somewhat round in nature, and I'm going to place them below the horizon line. We're just doing those cross sections. The degree of those is going to increase as I go further below the horizon line. Just keep that in mind. Again, they're not exactly ellipses, but they're still going to have that degree change as we go further down below. Drawing the perpendicular cross section. Going back towards left vanishing point. Let's do the same thing on this side. This one seems to be tilting away from us, so I'm going to pretend it's tilting away. Remember, back to our rotating of ellipses. Now, since this is going further away from us, the degree is going to increase as it goes away. So this one's going to be a little bit wider. Once again with that perpendicular cross section. Maybe if we want to make it look a little more like a cactus, we'll add some thorns coming out of this. Add a little cast shadow underneath there. Now there's these little fruits that are coming off, and they seem to be coming towards us, so I'm going to indicate that with the ellipse. This one's kind of facing away from us a little bit. It's all about just creating these perpendicular cross sections. Adding in those cast shadows really helps sell that volume too. I'll do another type of cactus, a little bit more round in shape, and I'll show you a different technique that we can use. So I'm just going to gesture in the shape of it. Now I'm going to place in the bottom ellipse because it has a circular base. I'm going to create an elliptical cross section. Now here's the minor axis, in this case vertical, and we're going to go up a little bit and create another cross section. In this case, the degree of the ellipse is going to be a little bit shallower because we're going closer towards the horizon line here. Now what I'm going to do is I'm going to add to this bottom ellipse. So imagine we're placing a flat shape on the ground plane. Just making these, adding to this cross section. Do the same thing up here. Now I'm going to start to connect these. And I'll bring it up to the top, and it sort of tapers in towards the top. As it tapers in towards the top, it begins to rotate away from us. So just account for that in your ellipses. Now I'm going to add some texture to try to sell this a little more. Has these sort of chunks down here and these segments. Adding in this texture helps sell those forms a little more. And you can follow the contour. I'll add in some of those spines from the cactus. Again, follow the contour of that shape there. Just imagine making that cross section again. Anywhere there's overlap, like here, it's good to just thicken up that line weight. It sells that overlap a bit more. All right, guys, I hope you enjoyed this longer form content. It's a little bit more dry and more like what I would teach in an actual classroom. If you want to get access to this content, you can subscribe on Patreon for $5 a month. That will give you access to all of the Gumroads I do each month, rather than buying them individually for $5. And if you somehow made it here from someplace other than my YouTube channel, be sure to check that out at youtube.com/moderndayjames. I'll be releasing a book in the near future, and I'm going to be working at Brainstorm School, so you can check those out as well. Thank you guys very much, and I'll talk to you soon.